High above us, shining brightly, is the sun. It's the star of our very own solar system. The sun's gravity keeps everything in our solar system, from giant planets to tiny specks of dust orbiting around it. Without the sun, our planet would be a cold, dark, and lifeless place. The sun bathes us in light and warmth, making life on Earth possible. Plants use the sun's energy to make food, and we rely on those plants and the animals that eat them for our survival. The sun is about 93 million miles away from Earth. Even light, which travels incredibly fast, takes about 8 minutes to reach us from the sun. In the grand scheme of the universe, the sun is just one star among billions, but for us, it's the most important star of all. The sun was born about 4.6 billion years ago from a giant cloud of gas and dust called the Solar Nebula. This cloud started to collapse under its own gravity, pulling all the gas and dust inwards. As the cloud collapsed, it spun faster and faster, flattening into a disk with most of the material concentrated in the center. The center became so dense and hot that nuclear fusion began, igniting the sun. The sun is mainly composed of two elements, hydrogen and helium. Inside this cosmic furnace, hydrogen atoms fuse together to form helium, releasing a tremendous amount of energy. The remaining tiny fraction of the sun's composition is made up of heavier elements like oxygen, carbon, neon, and iron. While these elements make up a small percentage, they are still crucial for understanding the sun's overall structure and behavior. The sun may look like a smooth ball of fire from Earth, but it's actually a complex and dynamic star with distinct layers. At the very heart of the sun lies the core, where the real action happens. It's incredibly dense and hot, reaching temperatures of over 27 million degrees Fahrenheit. Under these extreme conditions, hydrogen atoms are forced together in a process called nuclear fusion, releasing the energy that powers the sun. Surrounding the core is the radiative zone, where energy slowly makes its way outward in the form of radiation. Next comes the convective zone, characterized by churning currents of plasma, similar to boiling water in a pot. This process helps transport energy from the radiative zone to the sun's visible surface. Finally, we reach the photosphere, the layer we see from Earth, where sunspots, those dark, cooler regions on the sun's surface, are located. The photosphere is relatively cool compared to the sun's interior, with a temperature of about 10,000 degrees Fahrenheit. The sun isn't just a giant ball of fire sitting passively in space. It's a dynamic and active star, constantly releasing energy in various forms. One of the most visible signs of the sun's activity is sunspots, caused by intense magnetic fields that inhibit the flow of heat from the sun's interior. The sun also releases sudden bursts of energy known as solar flares, like giant explosions on the sun's surface. Solar flares can disrupt radio communications and even damage satellites orbiting Earth. Sometimes these eruptions release massive clouds of plasma called coronal mass ejections, CMEs. When a CME hits Earth's magnetic field, it can trigger beautiful auroras, or northern and southern lights. However, powerful CMEs can also disrupt power grids and cause widespread blackouts. The sun's activity follows an 11-year cycle, with periods of high activity characterized by frequent sunspots and solar flares, followed by quieter periods. Scientists are constantly monitoring the sun's activity to better understand these cycles and their potential impact on Earth. The sun also releases a stream of charged particles called the solar wind, influencing the entire solar system and creating stunning auroras.